Children, welcome to this video of number systems. Today we will discuss the laws of exponents for real numbers. Friends, we have studied the exponential rule for natural numbers in previous classes. As per the first rule, if a raised to power m is multiplied with a raised to power n, since the base are the same, both the powers are added. As per the second rule, multiplying the power inside the bracket, that is m by the power outside, is written like this. And here on dividing a raised to power m by a raised to power n results in a raised to power m minus n. As per the last rule, if the bases are different but the exponents are the same, then multiplying them gives the number to be written in this manner. Friends, have you noticed the third rule? There is a condition here. M is greater than n. That is, m must be greater than n. Let's look at an example to understand this. 2 raised to the power 4 divided by 2 raised to the power 2, where the value of m is 4 and the value of m equals to 2, that is, m is greater than n. If we use this rule here, we can change it to 2 raised to the power 4 minus 2. We'll write like this. We get 2 raised to the power 2 here, that is a positive number. Friends, can you guess what happens if m is smaller than n? Let's see if in the same example we have 0 instead of 4, m will be less than n. Here the power of 2 will be minus 2. That is, the power will be a negative number. We know that a raised to power 0 is equal to 1. We place a raised to power 0 instead of a raised to power m. We get a raised to power minus n, which is 1 by a raised to power n. Now we can use these rules for negative powers as well. Let's see some examples. If we use the first rule, we can write 2 raised to the power minus 4 multiplied by 2 raised to the power minus 2 as 2 raised to the power minus 6. In the second example, we'll use the second law. It has m equals to 2 and n equals to minus 4. So we multiply both the powers and write it as 2 raised to the power minus 8. And here we use the third rule. So we get 2 raised to the power minus 6. In this example, using the rule, we multiplied 2 by 3 and got this result. If we have numbers like real number and exponential rational number, can we apply these rules here too? Friends, let us understand this. If a number is given in a square root, that is, square root of 2, it means that its power is 1 by 2. And if cube roots are given, say cube root of 2, then it can be written as 2 raised to the power 1 by 3. And similarly, we can generalize that if nth root of a is given, then here we can say that it is a raised to the power 1 by n. Here a is a positive real number. Now look at this number, 9 raised to the power 3 by 2. We can write it in two ways. The first method is 9 raised to the power 3 by 2, which can be written as the square root of 9 in brackets to the whole power of 3. Square root of 9 is 3. 3 raised to the power of 3, and we get the result as 27. And in the second method, first we'll take the cube of base number and then the whole raised to the power 1 by 2. So cube of 9 is 729 and 729 raised to the power 1 by 2 is nothing but square root of 729, which is equal to 27. If the power of a real number is in the form of a fraction, and if the same fraction can be simplified further to make the calculation easier, the fraction should be written in its simplest form. As in this example, we divide 6 by 9 by 3 and we get 2 by 3. Looking at all these facts, we can say that if a is a positive real number and m and n are integers with no common factor other than 1, And if n is greater than 0, then a raised to the power m by n can be written as nth root of a the whole raised to the power m, or nth root of a raised to the power m. Now we can define the laws of exponents as if a and b are positive real numbers and p and q are rational numbers, then these laws will be something like this. Here all the laws remains the same and will be applicable in the same manner as we do for natural numbers. So that's it for today. In this session, we have discussed about the laws of exponents for real numbers.